Compounds are composed of two or more atoms bonded together to form molecules. Now, molecules are really small, so most of the time we talk about moles of a compound. A mole is 6.022 times 10 to the 23 molecules. But we can't measure moles directly. So therefore, in lab, most of the time, we measure the mass of the compound. And so we have these three representations, molecules, moles, and mass, and we need to convert between them. We can go from molecules to moles with Avogadro's number, mass to moles with molar mass. But what if we have to go from the number of molecules to the mass, or from the mass to the number of molecules? Well, in that case, we can't go directly. We have to go through the moles. Let's look at an example. So sand is composed of silicon dioxide, that's SiO2. There are 12.5 grams of silicon dioxide in a sample, and we want to know how many molecules this represents. So what we're going to do is we're going to go from 12.5 grams, that's our mass, to moles, and then from moles to molecules. And so what we have to do is we use the molar mass to go to moles and then Avogadro's number to go to molecules. So let's look at the molar or molecular mass. Now it's SiO2, so that means we have one silicon, which has a mass or a atomic mass from the periodic table of 28.09, and we have two oxygens, which have atomic mass of 16.00. So that's going to give me a molecular mass or a molar mass of 60.09 grams per mole. And that's what we're going to use in the next step. So we have 12.5 grams. We want to convert first to moles. So we use this 60.09 grams is 1 mole. The grams will cancel out. That'll get us moles. And then if we want to go to molecules, we need to have a conversion from moles to molecules. And that conversion is Avogadro's number. So 1 mole is 6.022 times 10 to the 23 molecules. So the grams will cancel out, the moles will cancel out, and this will give me 1.25 times 10 to the 23 molecules of my silicon dioxide. Notice the first step is always to go to moles, and then we can go from moles to molecules. Let's look at a problem in the reverse. So here we have 6.25 times 10 to the 21 molecules of silicon dioxide, and we want to figure out the mass. Well, in this case, we're going to go from the molecules to the moles and then to the mass. So the first thing we do is we start off with our molecules. 10 to the 21 molecules. We need something to go from molecules to moles. That's Avogadro's number. And then we need to go from moles to grams. And so here we're going to use our molar mass. Now we found the molar mass earlier. And so for silicon dioxide, it's always going to be 60.09. So if we do that calculation once, we don't have to do it a bunch of times. And so this is going to get me the grams of my answer. And that's going to be 0.624 grams of my silicon dioxide. I start off with 3 significant figures, so my answer has 3 significant figures.